if vector A is 1, -3, vector B 2, 3, and vector C is 8, 3, find I, M, and N such that vector C equals MA plus NB, where M and N are scalars. I find the magnitude of vector D if D equals C minus 2A. Now, the first thing I want you to pay attention here is that A, B, C are vectors. You can write a vector with a small letter, and when you do that, you have to bolden it. So if you look at it, because it is typed, the A is boldened, the B is boldened, the C is boldened, so this shows that these are vectors. And if you look at M and N, they are italicized, and M and N are not boldened, they are light, so you can see. And these are not vectors, these are scalars. So we are told that where M and N, as you can read here, where M and N are scalars. So when we say scalars, they are just numbers. A vector deals with a scalar and direction. A vector is a quantity that has got magnitude, size, or length, or scalar, and it has also got direction. Scalars have just magnitude or sizes, they don't have direction. So from what we see here, A, B, and C are vectors, while M and N are not vectors. All right, so let me put down the data that we have, and we can start solving what we've been asked to do. Now, in writing this, I cannot depend A to show that it is a vector. So I'll put a small scribble under the A to show that A is a vector. So this will differentiate the vectors from the scalars. So because B is a vector, you can see that B is bolding here, so I'll put a scribble under it, and then we have B, vector B2 equals to 3. Let me say this here. You can write a vector A as OA. When you write in capital letters, you have to use 2 letters. So OA means the vector A from the origin, and that is the same as the point A. You see, the point A is the vector OA, and that is the same as, if I want to use a small letter, then I have to do this and put a scribble under it to show that there is indeed a vector. All right, so let me go on with this. So the vector C to vector C is also 8, 3. All right, I says that I have to find M and N, where M and N are scalars, but I have an equation that involves M and N. It says that vector C equals the scalar M, then vector A plus the scalar N times vector B. So I am finding M, N. That is the 2 scalars. But do I know vector C? Here is vector C. So I'm going to use this equation to find M, N. That is very, very straightforward. Vector C is 8, 3. So I'll substitute 8, 3 here. And the scalar M, the number M, I don't know. That is what I'm finding. Vector A is 1, -3. So the scalar is multiplying the vector here, plus vector, it is the scalar N, so N here, and vector, B, the vector B is 2, 3 here. Okay, so that's what we have here. Now, when a scalar multiplies a vector, it multiplies each of the coordinates of the vector. Be very careful here. What we have here is we have M multiplying 2 numbers. This is a vector. These 2 numbers represent the X and Y coordinates respectively. All right, so let me write 8, 3. And here we have M times this vector. So we have M times 1. So what we're seeing here is that we are seeing M times the S coordinate, that is M times 1. Then we're also seeing M times the Y coordinate, that is M times -3. So that is what we're seeing here. And when we come down here too, we have this scalar multiplying 2 and 3. So we have N times 2 here, and we also have N times 3 here. Okay. So simplified, we're going to have something like this: 8 on 3. Then we have M times 1 is M, then M times -3 is -3M. We write the number first, and then plus N times 2, we have 2N, and N times 3, we have 3N. All right, so we have this that is called equality of vectors. We have the equal sign here. This means the terms on the right, when you sum them, you get the terms on the left. So we can equate the corresponding coordinates. That is to say, we can say that the 8, which is the S coordinate on the left, is equal to M, the sum of M and 2N, right here. And I can call this equation 1. then 3 2 is equal to negative 3m plus 3n, and I can also call this equation 2. All right, to solve this, I have to find one of the scalars first, and I have to eliminate one, then I find the other. So what am I gonna do? Okay, I am going to, should I eliminate? All right, I'm going to eliminate m. I will eliminate m and I'll find n. Now I'm using a method that we call the so-called method of elimination. That means that I'm going to find n, I'm going to eliminate, I'm going to get rid of m first. Now to get rid of m, I have to make sure that the coefficients of m are the same. Taking aside the sign, here is negative, forget about the sign here. Here we have m here. Now we have m here, then we have negative 3m here. Now to make this the same, I'm not talking about the signs. Here is positive m, and that is plus 1m here, as you can see here, and here is minus 3. I am not talking about these signs. I am talking about these scalars, the 1 and 3. They have to be the same before I can eliminate that. So here I have 1 here, so you take that 1, then you multiply it by the equation down here, then you take this 3, don't add the sign. I am not talking about the signs here. So I will have 3 times the whole of this equation. So 3 times 8, 8 is 24. Then 3 times m, I have 3m. 3 times 2n, I have 6n. That is a different equation. Let me call it equation 3. Then here 1 times the whole of this, I'll get the same thing back. 1 times 3, 1 times negative 3m, negative 3m, and 1 times 3n, I get 3n. Now because this and that, it is the same equation, I will just call it equation 2 here. Now if you look at the coefficient of m here, here is positive 3 and here is negative 3. So now I have them to be the same if you take out the signs. But because the signs are different, if the signs are different, we add. I kind of ask myself, how can I make sure that m goes to 0? If I subtract 3m from negative 3m, I don't get 0. Check it and see. 3m minus negative 3m, that gives me 6m. Or if I subtract 3m from negative 3m, I get negative 6m. The only way I will get 0 here is when I add 3m to negative 3m. So what I'm saying here is that let's take it as a rule. If you are using the method of elimination, after making the numerical coefficient of the variable you want to eliminate the same, the next thing is to look at the signs. If the signs are different, that is plus and minus, you just add them. Minus and plus, you add them. But if the signs are the same, negative, negative, you subtract. Positive, positive, you subtract. So 24 plus 3, sorry, that will be 27, because I want to eliminate m. If I subtract, it will not be eliminated. I have to add them. Sorry here. So 3m plus negative 3m, that will be 0, and 6n plus 3n, that will be 9n. Okay, so I have 27 equals 9n. To find n, you divide both sides by the coefficient of n, that is 9. So 9 3 27, so n is equal to 3. Okay, so now I can put the value of n into any of the equations. I'm picking equation 1, so I'll say put n equals 3 into equation 1, and equation 1 says 8 equals m plus 2n. 8 equals m plus 2n. All right, so that is equation 1. So if n is 3, then we're going to have something like that. So we have 8 equals m plus 2 times 3 is 6. You make m the subjects and you get 8 minus 6. So m is equal to 2. So the values of m and n are m is 2 and n is 3. So we have been able to find the values of m and n here, and that was pretty simple. Once again, I want to pull up my calculator and check this. After having these equations, you can also put these things into your calculator and you check it and see. I've been saying this, so I can reset this or I can just use this, but for the sake of clarity, I'm going to reset the calculator. To do that, press shift and press on 9, you can see CLR on it. That means clear. That is the second function. So shift clear, and I'm clearing. I am resetting everything. So I choose the number 3, that is reset all. Then you choose the equal sign, that is yes. Then you press AC to clear everything up. Now there is simultaneous equations, that is in two variables m and n. So what we're going to do is that the calculator uses x and y. So first we are going to assign these values. What we are going to do is that we will let our x be our m. So our x is our m and our y is our n. So where I have x, I will use m for that, and then where I have y, that will be n. All right, so you press mode and you choose equation number 5. You go to 1, which is used to solve simultaneous equations in two variables. 1, the coefficient of x in equation 1, that is the a1 is 1 here. You press on the equal sign. The second one for the y here is 2, press 2. And the last one, that is the constant, is 8. Here the constant is written on the left side, but you shouldn't be confused here. So that is 8. And you go to the equation 2, and here the a is -3. So you press -3, press on the equal sign, and here the b is 3. You press on 3, equal sign, and the constant here is on the left. You shouldn't be confused. It's the same thing being on the right or left, and here it is 3. So you press 3 and you press on the equal sign. So the first variable, that is x, is going to be our m. So press on the equal sign again, and x is 2, so that means m is 2. And when you check m, we had m to be 2 here. All right, and the next one, we had n to be 3. So you press on the equal sign again, and you have y is 3, and we had n2 to be 3. So you can alternate between these two answers, that is m and n, with the cursor, and that is how it is solved using the calculator. Now we go to the II. It says find the magnitude of this vector. All right, so it says that we are to find this, and this means magnitude of the vector d if d equals this. So first we need to find vector d, which is equal to vector c minus 2 times vector a. Now vector c is giving us 8, 3, so we put 8, 3 here. Minus 2 is a scalar multiplying the vector a, which is 1, -3. So before we can simplify this, we have to expand this. We have a scalar multiplying a vector, so we will first write 8, 3, then we will expand it. Be very careful here. I want to take my time here, so please pay attention here very well. Most students make a lot of mistake here. Now the number that you see here is -2, but there are two ways that you can work it. I am going to show you the two ways. As a matter of fact, I don't know which is the best, because it depends on how you understand what you're doing. Now I am going to write here method 1, and of course I like using the method 1 because it makes a lot of sense to me. And then method 2, some students are found doing this. Now that is it, the method 1. We have 8 on 3 minus 2, then we have 1 on -3. Method 2, let me write the same thing here. 8 on 3 minus 2, 1 on -3. I am calling it method, but practically they are the same thing. It is because of these negative signs here. The first method which I used is that the number here is of course -2. It is not 2. This sign affects this. So that is what I do. I use the -2 to multiply 1. So we will have -2 times 1. The whole of the -2, because the 2 is negative. And that's same -2 times -3 here. So if you look at what is happening here, I have used the entire -2 to multiply this. So you cannot again write negative here, because that negative sign is here. It has entered the bracket. So what is left in its stead is positive. I think you should understand that even if we write 3, 3, minus 2, we can say 3 plus minus 2 is the same thing. It's like adding 3 to negative 2. So most students have problems here. They will use the negative 2 to multiply this, all right, yet they will still write negative here. No. The moment the negative 2 enters the bracket, the sign here is positive. If there is no sign there, put a positive sign there. Now, the second thing is some of them also try to leave the negative sign here, which to me does not make sense because the 2 is affected by the negative sign. But, well, that will not also give you a wrong answer. It will give you the correct answer anyway. So if you leave the negative here, then that means you are going to have something like 2 times 1, then 2 times negative 3. I don't like it this way because it doesn't make sense. The negative 2 is attached to the 2, but the 2 give the same answer anyway. Let's see. 8 on 3. Then we have plus negative 2 times 1, we have negative 2. Negative 2 times negative 3, we have positive 6. Let's look at this one too. 8 on 3 minus 2 times 1, 2. 2 times negative 3, negative 6. So subtract this. Let's see what we get in here. So we have 8 plus negative 2. So that is what we are seeing. We have 8 plus negative 2. That is the top one. Then we have 3 plus 6. So that is what we're seeing here. And if you watch carefully, you will know that 8 plus negative 2 is the same as 8 minus 2. And 3 plus 6 is 9. Let me also check here. So here too we will have 8 minus 2. So you can see that we have the 8 minus 2 there. Then here too we have 3 minus negative 6. And when these two signs meet, it turns to positive. So we have 8 minus 2 here. Then we have 3 minus negative 6 is 3 plus 6. So you see what we are getting here for the 2. So 8 minus 2 is 6 or 9. Then 8 minus 2 is 6. 3 plus 6. 8 minus 2 is 6, yes. And 3 plus 6 is 9. So you can see that we are getting the same answers for the two methods. But as I did say, I will urge you to look at this first one because the negative sign, of course, affects the 2. So you cannot just leave it there and think that is okay for the sake of what you'll be doing next, because at times if you keep doing this, you might forget to always make sure that the number that the negative sign affects is well catered for. So try and do it this way so that it becomes a second nature, you see, because the negative sign affects the 2. Don't leave it there this way and send the 2 in there, although you get the same answer. I want the method 1. All right, so that is how we find D. So the vector D is 6 or 9, and you are not done yet. It says find the magnitude of the vector D. So that is the vector D. All right, the magnitude will be the square roots of the x part, that is 6 squared, and the y part, that is 9 squared, and that will be equal to the root of 6 squared is 36, 9 squared is 81, and this should be equal to 117 units. And when you change this to decimals, let's see what we get from decimals. So let me pull up my calculator, and then I am in the equation mode. So you just press mode, then you press 1, you go to the normal computation mode, and you are okay. There is no need to reset here. So what is the roots of 117? Okay, 3 root 13, and you can change it to decimals, and that should be 10.16. So let me get back to the third. So simplified, I have 3 root 13 units, and that should be okay for that.